Take it away, Peter.
All right. Good afternoon, everybody. I'm happy to my first presentation to the Kansas City group. Um, I kind of wish it were in person because I could always go for more barbecue.
Oh
So
yeah,
we're
we'd
going to
be
talk about,
more than happy to give you barbecue whenever you're out here. Just let me know.
will do. So we're going to talk about secrets of the plan cache today. But before we get to that, a little bit about me. I am a SQL Server database administrator at Chipotle Mexican Grill. And yes, if in case you're wondering, one of the pieces of my compensation is access to burritos, which is a nice little perk. I mean, intentionally accidental DBA simply means that I look like the accidental DBA classic resume, except I'm just goofy enough to have done it on purpose. I've been around IT for over 25 years. We're getting scarily close, frankly, to 30. And I grew up on the infrastructure side of the house. I am not a developer. I am the president of CBus Data, the user group here in Columbus, Ohio. And when we had and or have again such things, I help co-run SQL Saturday Columbus. I am easily found at pshore73 on Twitter. Any of you who are on Twitter probably are well aware that I tweet somewhere between frequently and too darn much. You can see my email address and the funny looking duck face. I am in the 2020-2021 IDERA ACE class, which is a great program that IDERA runs that helps some folks. Well, when we were doing in person, they were helping us get to events. Now they're helping us with exposure through some of their Geek Syncs and blog posts. So, secrets of the plan cache. I should start by giving credit. Most of the queries we're going to look at today were actually written by Jonathan Cahias of SQL Skills. He is very much aware that I am doing this presentation. I talked to him about it. And in fact, I've done it for the Cleveland user group with his coworker, whom you may all know, Aaron Stellato, sitting right in the room. So there's no way Jonathan doesn't know that I have made a presentation out of his queries. I should also note that as we get more and more into Query Store, some of this information is also easily found there. However, I don't cover any of that because this is not secrets of Query Store. This is secrets of the plan cache. However, we don't need any of these things. We don't need Rosetta Stone. We don't need any fancy translations. We don't need Holmes. Heck, we don't even need Scooby-Doo. Why? Because there are no secrets in the plan cache. Now, what do I mean by that? Well, nothing's obfuscated. Nothing's intentionally hidden. We're not doing any weird hacks to get at any of this information. The weirdest thing we're doing is querying the plan cache, which is not the first thing people necessarily think about doing. But where's plan come from? And this is a very short version of this, and we're keeping it high level. When you run a query, whether it's from Management Studio, Azure Data Studio, your favorite web app, or somewhere else, the query gets to the SQL Server data engine, and the query parser is going to check for syntactical correctness, make sure that you have written a proper T-SQL query, but it's not going to confirm the existence of any of the related relevant referenced columns or tables. It's just going to make sure your T-SQL is correct. We're going to go through a binding process at that point that then confirms that the columns, tables, views, objects exist and you have access to them. And this builds the process tree that gets handed off to the query optimizer where the query plan is built. And when the query plan is built, the things you need to remember for this presentation are statistics are very important. Up-to-date statistics have an unbelievable influence on the building of the plan. SQL Server's goal is to create a query plan that will bring back the data in the least amount of time possible using what it knows about the data from the statistics and what it knows about the databases themselves, processor, a few other things. But also the SQL Server has a limited time in which to build that plan. In fact, if you were to look at a query plan and the properties of the query plan, it would say reason, it would give you the reason that this plan is in use is it was the best good enough plan selected, which means it could be the perfect plan. It's statistically possible, but it's also statistically unlikely. And in fact, I've heard tale that for particularly complex queries, it can take something along the order of days to come up with the perfect query plan. And I don't know about your users, but my users don't like to wait seconds for query results. Days is well out that window. So let's take a quick look at a query plan. Where did my query plan go? I know oh, there it is. I'm looking for the wrong icon. Plan Explorer updated with the with the SolarWinds icon, and I keep looking for the SQL Sentry icon. So here is a query plan, and yes, I have Zoom it installed, and we'll need that later. But for the moment, I have multiple query plans open, and what we see here is it's a select query. I think I ran this at one point against the Stack Overflow database. And we can see we have a query plan. We've got a bunch of objects, some index scans, some hash matches, a not overly simplistic query plan, but also a not, here's an overly simplistic query plan, but also on the order of things, not the world's most complicated query plan either. Now, here's the reality of the situation. Microsoft does not store the query plan in the plan cache with these objects in it, of course. That doesn't make any sense. Microsoft is a text-based company still. I know you're all going, well, they have Windows. And I don't mean just Windows Server Core. Think about it. In all the times you've ever done anything in Windows, the reality is that you can do 2/3 of anything you particularly need to do in a given GUI, right? But if you go out to a command prompt, out to PowerShell maybe, you can do all of what you need to do in one command and probably more options than there are in any of the command windows. The same thing in SQL Server, right? You can do the GUI in Management Studio for backups or stores. And then if you write the T-SQL, there are a plethora of additional options. The reality is the query plan is also stored in text. And I'm about to say a dirty word here, perhaps to some of you. It is stored in XML. The good news is XML is queryable. The less than good news is you have to write XQuery to query it. But this is a sample query plan. In fact, you can see it's this query plan right here. There's a lot of information in here about the plan that doesn't show up in the picture. Maybe if you maybe some of it shows up if you are over a particular nodule. So we can see the memory. We can also see the database, memory grant info. There's a lot of information in here. We can see, I believe it's SQL Server 2016 or higher. We can see the statistics that are used, which is, of course, very useful information as we troubleshoot things. We can see weights. We can also see, let me see if I have where I can find it in here real quick. We can see what indexes were used, what columns are referenced, everything in this query plan, which means we can query it in the plan cache. So let's switch back to the slide deck. and talk about what the plan cache actually is. It's a subset of the buffer pool. So yes, if your plan cache is large, you're taking memory away from the pages or from the space that SQL Server can use to store pages, so you don't have to incur I/O. On the other hand, if the plan cache is too small, we're regenerating a lot of plans. It holds each query plan or a stub of the query plan. If it's a single run ad hoc query, if optimized for ad hoc is true, it's going to hold the stub of that query plan. And if that query is run a second time, it will then cache the entire plan. Sounds like somebody's not on mute. If you're not on mute, could you mute yourself, please? Of course, we can also clear the plan cache through many different methods. Through the DBCCs of free proc cache with a specific plan, system cache, flush in DB. It is also important to remember that if you update statistics, any query plan that uses a statistic that was updated is going to be flushed from cache. That's a good thing in the end. Why? Because that means that query plan is going to be rebuilt with a more up-to-date version of the statistic. Gives a better query plan potentially. Index maintenance, specifically rebuilds, since they update statistics, are going to force the plan out of cache as well. Memory pressure will also reduce the size of our plan cache. It'll force plans out of cache. And not surprisingly, a reboot or a restart of SQL Server will drain the plan cache. It's really important to remember that the plan cache is not persisted and that things can be flushed out of it relatively easily as we start to do some of these investigations through the plan cache, because while we may get a lot of results for some of these queries, it doesn't necessarily mean we're covering all situations. On the other hand, on a lot of these queries, I filter out single-use plans anyway. But let's talk about xquery, because that's how we're going to get the plans out of the plan cache. Xquery is language used to find and extract both the elements and the attributes from the XML documents, but it is not T-SQL and it's not specific to SQL Server. It is its own thing that is compatible with SQL Server, and it's compatible with XML and namespaces, XPath, XML schemas, and things along that line. But it is not explicitly T-SQL. So if you're writing your own versions of these queries, you're going to need to review some xquery. There's a command with XML namespaces that defines the specifications of the XML namespace being used within the T-SQL. And the URL there, the schemas.microsoft.com/SQL Server/2004/07/show plan, is the schema map for SQL Server. And we need that with XML namespaces in order to put XML in the from clause. So let's take a look at some of these queries. I apologize. I really like to run some of these live, but I blew up my test environment today and doing something entirely unrelated to something else up on a different part of the system, and things aren't working quite right. So we're going to look through, and I'll show these queries in a little more readable way here in just a moment. Cost threshold of parallelism is, of course, important to us because we want to tune it. It is a tunable number, right? We can change that number. It's not just set it at 50 and forget it. I mean, 50 is a good starting point, but is it the right point for us? It's the classic answer. Well, what do you set some setting at? Well, I set it at this, and then I monitor to see if I change it. Well, how do we monitor that in SQL Server? For the cost threshold, we run a query we can pull this out of the plan cache, and we can see in the result set, and I'm going to try and avoid zoom it so I don't get anybody seasick. We get the actual plan. Because I stole these out of a production environment, I have obfuscated the statement text, and I've obfuscated some other things in some of the other queries. Sorry, but I needed to do that. We can look at the optimization level. And here's the key column for this, one of the two, in my opinion. The statement subtree cost, which in this case is the subtree cost of the entire query. And the other one that I find important is the use counts, because we want to see how many times a particular query is being used. Because it's quite plausible that we get a query that is run once and has a high use count. In fact, cost. In fact, this query itself has a fairly high cost to it when we run it. Now, I'd like to point something out. In Jonathan's original code, he has this as a varchar 128. I changed it to float because xquery can deal with a float, and it meant that I could do the order by, well, this one I have order by use counts, but sometimes I like to order by cost, and without that being a float, the order by gets a little weird when you're trying to order by text numbers that are text, because suddenly 10 comes right after 1. So I changed that to a float, and I wanted to call that out. So let's flip over and take a look at this in a little bit larger text. Oh, there it is. All right, so Jonathan is doing the set of the isolation level to read uncommitted. With the XML namespaces, here's that URL that we talked about. And now it's just a select statement. N.value is how we read those columns from the XML. The XML, we are doing some cross apply with the query plan and the plan handle from dmexec query plan. Query plan nodes, query plan.nodes is XML that we're cross applying. I have, these are some common things that I do. Like I'll sometimes do use counts over 50 depending on what I'm trying to find. Your environment. We can turn on or off whether or not the query, we're looking for queries that have gone parallel. It's a 0 or 1 situation. Here in this saved version, I'm looking for queries that have run more than 10 times, because I often don't care if that query has run once. And just to clean up the results set, I'm eliminating trivial plans. And in this case, I saved them where the cost of the query was over 100. I was looking for specifically high cost query plans. So it's really not all that different from a normal query, except it's got some xquery in it. This is the same plan, or the same query, sorry, not the same plan, but this time I've got it sorted by subtree cost and then use count. So why is that? Because not only can we use this, well, first of all, doing it this way, we can look at the costs and we can see if there's a natural breaking point. I've seen, in fact, I have a system in the office right now that I need to put in a change control to possibly change the cost threshold because it's set at 40. I've got a large number of queries with a large number of executions whose cost is all in like that 42, 43, 44 range. And frankly, I'm not sure that they're benefiting from going parallel. They may be eating threads that it would make more sense to not use and leave them single threaded. So I'm looking and then there's a huge break. It's like 46 is the highest in that cluster, and then the next highest that runs consistently is like at 80. So I'm looking to potentially bump my cost threshold of parallelism up to maybe 50 or 55. Let those other queries run single threaded. So that's one of the uses, and that's really what Jonathan wrote this query for in the first place. I realized that this query gave us another piece of information that is very, very useful. When we sort by the statement subtree cost, and that subtree cost is high, like this one here, it's 21,383.9. And the query, okay, that one's only run only 26 times. Somebody's probably already thinking what I'm thinking. Why is that query so expensive? Can we do something to make it less expensive? The secondary piece of information that we get out of the tuning the cost threshold for parallelism query is queries that are potentially problematic, that are using a lot of resources. They have high costs. Maybe it's just statistics updates. Maybe we need index maintenance. Maybe we need to rewrite the query. This is another way we can find some of those problematic queries. Maybe some queries that people aren't complaining about. Maybe some that are, for whatever reason, aren't bubbling up in other places. I had one that had a very high cost, was very highly used, and I started to look at it, and it was a case of even when I started adding indexes, I helped it some, and tuning indexes, I helped it some. But what I came to learn after looking at that was I needed to change my statistics update from using the default to doing a full scan, because that particular query was hitting some tables that had a lot of different information in them, and I needed a better statistics sample. I took it from a cost of well over 2,000 to a cost of 2. It by itself was pushing us to thread starvation during heavy utilization periods. Thread pool weights. I don't know about you. Thread pool weights are my least favorite, most scary weight, because to me they are the servers about to fall over and die. So the combination of high cost, high utilization made it a screaming query that needed to be addressed, that I found because I was actually trying to make sure the cost threshold of parallelism was set to something decent. You can see in here, in this sample run, this 570 at 71 is probably one I would look at ahead of 101 at, or 130 at 14. Is there any questions so far? I've kind of missed a point where I should have paused.
I guess the only comment I have is that you're using your order by based on your statement subtree cost and then by use counts. Right. How often do you have where your statement subtree cost? I mean, I do see on rows, 13, 14, your statement subtree cost is the same with different use counts. Are those just like different plans for the same, maybe potentially for the same query?
I have seen that be different plans for the same query. I have seen that just be happenstance that they were exactly the same. Mm-hmm. If I remember correctly, in this case, they're the same. In fact, yeah, if you look at the SQL handle on those, they are the same query. And that helps too, because you start to see that, and there are more questions to ask as well. Mm-hmm. And you're not necessarily, you could sort by the SQL handle, but I like to sort by and see that duplication of plan. I will admit it's been long enough since I took this screenshot that I don't remember exactly what the queries were for me to give any insight without giving the query away. But yeah, and that's a case of where I would really be looking at that query, because now it's a cost of 100, and now my runtime or my use counts are closer to 100. So it's now becoming a more frequently run query. It's using more resources. Can I adjust that query? Because remember, part of performance tuning is to make resources across the board more efficiently used. So it is very plausible that that query is taking resources away from another query that could benefit from them. Does that answer your question?
Yeah. Just was asking about your choice there. Thank you.
Yep, no problem. Anybody else have any questions? All right, so cost threshold of parallelism is great, but what else can we do? I mean, this whole session's not built around that, right? Well, of course, the plan cache is a great place to go investigating missing indexes. Now, there are multiple versions of ways you can do this. This happens to be Jonathan's. I know Aaron Bertrand has a really nice query that uses the plan cache to also look at missing indexes and how often those indexes are being used and where they're and where there's cross impact for those indexed columns. It is a much deeper query. And now that I'm talking about it like that, I probably should integrate it into this presentation. So hopefully I'll get to that on the next version of this one. You can see in the XML here, let's actually look at the query. Let's actually look at the query. This is a very different query because we're looking at different nodes, because we're pulling out the tables and the schemas in the database so that we can get those missing index values. We're pulling also the columns and the inequality. Again, I pulled this from a production database, so I have to obfuscate a lot of the result set because this is supposed to be my backup version. Jonathan pulls it into a temp table, and we pull out from the temp table. And then he just has some cleanup that he put in there to clean up a few pieces of the code and the result set. So if we go back and let's talk through this one. Again, we've got the query plan. We've got the SQL text so we can go look at it. We've got the impact of the missing indexes, the database ID, the object ID. We would have the actual SQL text and the equality, inequality, and include columns. Jonathan pulls all of that together so we can start to look at those missing index hints to see, of course, if they actually make sense to use. And where can we get some economy by combining indexes? All the things that you already know most likely about, hey, we don't want to do every index DTA recommends. Every missing index doesn't need to be there because there may be 12 hints or 12 comments of missing index that can really be alleviated in 2 because of overlapping columns and included columns, and the way the structure of the queries is and the way the structure of those indexes is. They're just slightly different. They can be combined. This missing index query provides us a way to start to look at that in the plan cache. And as I said, there are plenty of other versions of this, so you can start to do that analysis beforehand. And this isn't the only way. I would say make sure you're doing this analysis before you start creating indexes. This one is key lookups. And this is a pet peeve of mine, and is becoming an even more so pet peeve of mine in my current environment. We're looking for key lookups here. And the reason they're a pet peeve of mine, of course, is they generate extra I/O. If you are if the majority of your environment is Azure SQL VMs, be aware that Azure SQL VMs have a maximum I/O throughput for the individual VM. And that is usually less than any of the disks. And it can cause query performance issues because it waits until the throughput drops below the maximum. It'll throttle you a little bit. So you want to eliminate some of these pains like key lookups. And in order to do that, you need to go find them. And we'll visit this query. And again, it's a very similar structure. We're going through and looking at the nodes. And we're looking for the physical op. We're looking through some different pieces. Of course, we need the database, the schema, the table, and the index. Having the index really helps because now we can go look and see where we need to add or include columns, what we need to add. And we're looking at the lookup equals 1, which is a key lookup, if I remember correctly, to find the key lookups in our query. Switching back to, now we can walk through the results set real quick. Again, SQL text, the actual operation, database schema, table, index name, use counts, because we want to get rid of the biggest ones first. And of course, if we were seeing the tables and the indexes and the SQL statements, we would of course be able to identify additional problems, right? We might have a case of, this one that has 6,500 and some odd uses may also overlap with this 139 and this 278 and this 24 and become a bigger number. It could combine with the other massive number here and really become big. And that helps us provide where to focus, helps us look at our biggest impact to the query plans. Now, I will say that if I were running any one of these queries, I would look at, and I opened the plan, I'm going to work on all of the problems I see. I'm not going to work on just cost and then just key lookups and just this and just that, right? There's some smart behind the decisions we make to decide how we're going to approach it and get the biggest bang for our buck. DBAs, let's do the most work we can to be as lazy as possible. That's why we automate things. But back to this. This pulls out the key lookups in a relatively efficient manner. And I should say that these queries are not always fast. Querying XML is not necessarily fast. And depending on the size of your plan cache, this can take a little while. So be patient. If you have other folks who are particularly itchy and twitchy at watching jobs run and get really concerned when they see things running for a while, be aware that you may get their attention. I have some of those folks in my BI team, and frankly, I'm often trying to fix stuff on their server. So I just tell them, hey, I'm working on your server. I need to look at this information. I'm trying to help you. When we look at query plans and the lack of index utilization, one of the biggest things, at least when I look at query plans, one of the biggest things I have seen over the last several years is, of course, related to ORMs and developers who leave default settings in ORMs, and we don't get proper data type matches. We get implicit conversions. It becomes very quick for me these days to go, oh, this query looks like this. The parameter it's passing in is an nvarchar 4000. This is written in an ORM, and the developer never looked at the query. What I'm troubleshooting? Implicit conversions. Those always have to go back to the developer, at least in my where I've been, because I'm not the one writing the code that goes against it. The probably most egregious one in this result set is the varchar 2000 that converts to an int. Because, of course, if we're doing an implicit conversion in the where clause, SQL Server cannot use that piece of the predicate to leverage any indexes, which means we're going to do table scans because there's no index that we can use. Generally, implicit conversions that are just a conversion of length don't have a negative impact. It's when we're converting types that the impact is most seen.
I'm going to go ahead and ask you right now then, Peter, where'd you get, is this one of Jonathan's queries for the implicit?
Yep. Yep.
It's a lot better than the one I currently use, because I like how you've got it listed from the converting from and the to, and how you have it listed out that way, as well as the lengths. Mine currently doesn't show. So,
yeah, right. This is another one I stole from Jonathan. I am not a terrible query writer, but I am a lazy query writer. If there's somebody who can write a better query than I am absolutely going to borrow it and give it attribution whenever I talk about it, whether it is in an internal conversation or in a presentation like this. In fact, as I go back over here, oh no, I didn't do it on this. I did it on, see, I put his name in the CTP check one. All of where I have them saved on my work computer, they all say Cahias _ and what it does.
Mm-hmm.
So let's take a better look at this one. So again, a lot of XML or XQuery to get these values out, but it's all in the plan cache. It's all in that XML in the plan, so we can relatively easily get the scheme of the table, the column, the data types, what it's actually converting to. And then we just put it back out again. This one, I think it was this one that I spent a whole whopping like 10 minutes messing around with, trying to get the use counts as well into it. And I didn't succeed. I got distracted, had to work on something else, and never got back to it. Because that's the one piece of information I would like to have here. Or I should say that I would like to have here in the result set is the use count of these queries, so that I can do some prioritization. And I didn't get that in there. Like I said, I think it was a case of it didn't work the first time, and then somebody asked me a question, and I went down another rabbit hole and never got back to it.
No, I agree with you on that. That would be a great use thing to get added in there. So,
yeah. But this one has definitely this, and key lookups are two that are going to help optimize performance really quickly on your system. Well, help you find bottlenecks is probably the better way to say that, because they're both going to lead you to places where you've got ineffective index utilization.
Right.
And those are going to help in the long run save things, because you don't really need to rewrite the query. We just need to make the query use indexes a little better, or have it run against indexes that are being more efficiently used and including all the columns necessary. As far as implicit conversions go, I had a case last summer where we were looking at some thread starvation starting to build, and they couldn't figure it out. And I said, there's an implicit conversion here. And the developer was like, no, that can't be it. I've checked all that. I was like, humor me. do that. And he ran a few tests and we looked at it. And I said, well, before you did that, it was this, and now it's this, and I got a much less, even though it was work, I got a much less safe for work reply back in chat that's along the lines of, gosh darn ORMs, you can make the changes to the words as you see not fit. But it was very helpful because it brought a couple of indexes in right away just by getting rid of the implicit conversion. Oh, this is a second run of the implicit conversion query, and this shows some of the other data types. So we can see some money to decimal. For those of you who don't know, money is a valid data type in SQL Server. There is no matching data type in Entity Framework. So this is an implicit conversion that cannot be fixed without changing the table structure. It's not a code fix, it's a table fix. And here we see a date time to int to big int's usually not a big deal. I found date time to to be a bigger deal than I expected it to be, if I recall correctly. I didn't think it was going to be a problem because it's still dates, and it was. Now, up to this point, we've been looking for things that are obviously broken. This query twists things, changes things a little bit. What we're doing here is we're querying the plan cache to find out what queries are using a particular index. It's not necessarily a current problem. However, perhaps we need to change this index. And the fact that this says clustered index probably means that this example is probably not the best relative to this result set, but just work with me. If this were a non-clustered index, say, and it was one that we had identified from our key lookups query that we needed to include, but we wanted to know generally what queries, what plans, what potential result sets and operations were going to be affected by by changing this query, because all those plans, remember, when we rebuild this query to add the includes and maybe adjust some indexed columns, that rebuild is going to clear the plan cache of all the plans that use that index. We may want to know what all of those plans are going to be. Maybe there's something we need to worry about in there. Maybe there's not. We just want to know. Maybe somebody's asking us from a change control board kind of perspective. Who knows why somebody's asking that question? But we need to know what the index is. We can use the plan cache, of course, to look up what's using the index. So we have to pass a table in, of course, because it's a specific index. We're looking for a specific index. We're going to pass the table in, and it's going to bring, and all of the queries that are hitting that table are going to pull back the indexes they're using. And then we can go in and look at what specific indexes. One of the things that I really want to rewrite, my first perhaps foray into the fun of XQuery, is for SQL Server 2016 and higher. I want to see what statistics are being used most often so that I can do some surgical statistics updating. because I've got some really big tables and some really nasty queries, and I don't want to update all of the statistics. I just want to update the ones that are being used all of the time. So do we have any questions at this point?
No real questions, just really liking some of these queries and want to make sure I can get a copy of them when you're, or at least a link to where I can get them from Jonathan. Hey.
Just so happens that we're up to the more info credits and references slide. That was not planned, but well done, Daniel.
They say good questions. You know, this is a great question because your answer's on the next slide.
Right. Good questions are later in the slide deck. Great questions are on the next slide. So yeah, they're all in Jonathan's blog at SQL Skills. Is really the fast way to say that. And even the one from SQL Performance, I believe Jonathan wrote as well. If Jonathan didn't write it, Aaron Stellato wrote it and referenced some of Jonathan's stuff. As I said, these are all the queries I showed today are originally written by Jonathan Cahias, not by me. And in some cases, they were written for different reasons that I ended up using them. The one, and like I said, the one thing that I really want to add is the statistics one, since SQL Server 2016 and higher recorded statistics in the plan, so they can be more surgical with the statistics updates. And as I said, they do take a while to run these queries if your plan cache is rather large. And I do have, at least personally, I do have at least one server where the plan cache is not tiny. And I've seen some of these queries take 45 minutes to run and come back with hundreds and hundreds and hundreds of results of cached plans, if not more. So just be aware of that. XML is a little bit resource intensive, particularly CPU. The X query, so be aware, but I wouldn't be scared of it, because since they're all running in isolation and they're also not doing anything to the transaction log, killing them if you need to, they die right away. There's no rollback. So they're safe to use in production from that perspective. Like I said, just don't use them when you're at like peak CPU. That might not be your best choice unless your peak CPU is really tiny. So what other questions can I answer? I did warn you that this is one of my shorter presentations. And since my mouth is still in speed through the other presentation, I probably talked faster than I usually do.
Yeah, I mean, I was thinking about some of the ways that I go through it, and I like the query for pulling, you know, what queries are using a specific index, because yeah, when I'm putting together some really in-depth index tuning queries for, you know, what are the missing indexes I have, what are the implicit conversions, what are the eager spools that I have, you know, within the plan cache, and then going about, you know, what's my current index usage. You know, what's my table structure and all that. So when I start giving better, it helps me to give better, you know, index recommendations. And so now I can even say like, oh, okay, what queries use this current index that maybe I want to modify, and will that be a detriment and such like that.
Right.
Yeah. But yeah, this is incredibly useful. So I appreciate it.
Yeah. Yeah, and you said something in there that I forgot to mention. You said you look for eager spools. So anything that's in a plan that is stored in the XML, you can mess around with the X query and find it. So while we looked at some practical queries that Jonathan has written, you know, Daniel, you said you look for eager spools. You could look for eager spools. You could look for lazy spools. You could look for, you know, if you can figure out how to extract it from the query plan as part of the X query, you can go looking for it. So there's a lot more power in querying the plan cache than we even talked about today. It's a matter of figuring out what you need and a matter of figuring out how to get that out of the plan cache. There are specific situations where, maybe you have an environment where you need to go find all the queries that are doing sorts because you want to see if you can get them sorted at the application layer. You can go find that. As a random example, I know, but it's not, querying the plan cache is not limited to these samples. It's limited to what you can figure out how to extract from the XML.
Yep. Anybody else?
Any other questions? It looks like no. Anybody have any questions that are not real? I'm going to stop sharing.
Yeah, and I'll go ahead and stop the recording now in case somebody's worried about that.